Okay, we'll start the class. 1 minute. In the last class, we are doing the problems on Thevenin's theorem. We'll do some more problems on Thevenin's theorem. Take on the problem. Draw the circuit. Calculate the current in 4 ohms. Calculate the current in 4 ohms using Thevenin's theorem. Calculate the current in 4 ohms using Thevenin's theorem. Calculate the current in 4 ohms using Thevenin's theorem. Okay, what is the first step?
Remove resistance
Which
In
resistance?
branch, yes,
determine current.
Which resistance you have to open?
4 ohms.
4 ohms. Okay. Okay. Draw this circuit. We have to determine VTH now. So for determining VTH, what you have to do?
Reference direction.
We have to consider one reference direction. In the open loop, where is open loop? Here. Here we are having open loop. In this open loop, I will consider one reference direction, whether in the clockwise direction or anti-clockwise direction. It is your wish. Okay. Now, if you want to determine VTH, I want the voltage in 6 ohm. I want the voltage in 2 ohms. If I know the voltage here and here, I can write the loop equation. If I know the voltage in 6 ohms and voltage in 2 ohms, I can determine VTH. So I want the current, I want the voltage in this and in this. So here, here one closed loop is there. Here I can consider one direction. Here I can consider the current because closed loop is there. This is not the current direction. This is only reference direction. This is reference direction. I can consider because why reference direction means that is open circuit. That is the open loop. In the open loop for determining VTH, wherever VTH is there, I will consider the reference direction. Now I had to determine the current here. This is the closed loop. 3 and 6 are parallel or series?
Series.
Series. Because current is not dividing here. Here open circuit is there. 3 and 6 are series. Therefore, in the direction of current, we can take plus and minus. This is the direction. For this current, I am taking plus and not for this reference. Only for the current direction, I will take plus and minus. See here one more loop is there. Current is flowing in the upward direction. Like this current is flowing. In this direction, I will take plus and minus for 2 ohms. See current is flowing, arrow is upward. Current is flowing like this. current in this. In series, current will be same. Whatever the current flowing in 3, the same current will flow in 6 also. Therefore, I is equal to V by R equivalent. V is 12. 3 and 6 are in series. 12 by 9. That is
1.33.
1.33
Okay.
ampere. That is the current flowing. In 3 ohms and 6 ohms, same current will flow because current in series is same. Therefore, in 6 ohms, we have determined the current 1.33 ampere. Now, I will determine the voltage in 2 ohms. Voltage in 2 ohms. These two are parallel. If they are in parallel, I into R. I is 10, resistance is 2, 10 volts. Voltage in 2 ohms is 20 volts. Voltage in 2 ohms is 20 volts. Okay. Now I'll write the based on this reference direction, I'll write the voltage here. See here, plus to minus VTH, plus to minus voltage in 2 ohms, minus to plus voltage in 6 ohm. Sum of all voltage in this loop is 0. Now in the direction of current, I had taken plus and minus, not for this reference. This direction I had taken plus minus. Based on this current direction, I had taken here plus minus. Now minus VTH. What is the voltage in 2 ohms?
Minus 20 volts.
20 volts. Plus voltage in 6 ohms. Here voltage in 6 ohms is 6 into I is equal to 0. So I value, you know, current in 6 ohms, 1.33. If we substitute 6 into I is 1.33, we'll get VTH. What is VTH? Tell me. Minus
12.02.
how much?
12.02.
Okay. Minus 12 or plus 12?
Minus 12.
Minus 12. Minus 12 volts. Okay, that is VTH. Now here, instead of going for the current, I can apply voltage divider here. See here, I will apply voltage divider. Instead of 6 into I, see here, voltage in 6 ohms. 3 and 6 are in series. In series, we can apply voltage divider. What is the total voltage for 3 and 6?
12.
12. Same branch resistance divided by
9.
sum of resistances of series connection. How much you will get here? 12 into 6 by 9, how much?
8.
8.
Now what is the value you will
8.
get here? Minus 12. Same thing you will get. Whether you apply voltage divider here or determine the current and substitute 6 into I. That is the voltage. 6 into I is the voltage. Directly you can apply voltage divider and we can determine the voltage here also. So this is the VTH. Now we have determined VTH here. Now we'll go for RTH. For RTH, what we will do?
Short circuit all voltage
Open
and
circuit.
open current sources.
Okay, short circuit all voltage sources and open circuit all current sources. See here, I am short circuiting this 12 volts and open circuit this current sources. See that I am opening the current source and short circuiting the voltage source. Now I will determine VTH. Previously 3 and 6 are in series while determining VTH. Now 3 and 6 are in
Parallel.
Parallel. Parallel.
we can connect 3 here, then 3 and 6 are in parallel. Therefore, RTH is equal to 3 and 6 parallel in series with 2. Here open circuit is there. That is your RTH.
Four, sir. Four, sir.
Okay, 4 ohms. Okay. In textbook they have given 4 ohms. In your textbook they have given 4 ohms. Now draw the equivalent circuit VTH and RTH. What is the resistance you have removed?
4.
4 or 4 ohms? Okay.
4 ohms.
Okay, 4 ohms. Now I will determine the current in this 4 ohms. I is equal to VTH by RTH plus 4. All are in series. VTH, RTH and 4 are in series. In Thevenin's theorem, always resistance will be in series with the voltage. In Thevenin's theorem, always resistance, equivalent resistance will be in series with the equivalent voltage. And what are the resistance you have removed that will be connected in series with VTH and RTH? You will get 1.5 ampere minus
It's
1.5.
1.5.
1.5. Minus 1.5.
Okay, this is your answer. In this, we will determine the current by using Thevenin's theorem. Okay, next problem.
Sir, your screen is not visible.
What happened?
It's visible, sir.
Okay.
Now visible.
Write down the question. Determine the current in 6 ohms. Determine the current in RL. RL is the load resistance. Determine the current in RL. RL means load resistance. Determine the current in RL. Determine the current in RL. Here it is RL. This is RL. RL means load resistance. Determine the current in RL. R suffix L. Determine the current in RL, load resistance, using Thevenin's theorem. Using Thevenin's theorem. Okay, what is the first step we have to do?
Short circuit the 6 ohm.
Remove the resistance in the branch.
This is open circuit, not short circuit. We will open the resistance RL. RL is 6 ohms. RL load resistance is 6 ohms. Draw the circuit. Draw one more circuit. Here, how many nodes are okay? Don't go for the nodes. Later we'll discuss. Shall we apply mesh analysis for determining VTH? We'll apply mesh analysis because
Yes,
two loops are there here. Before taking the loops, I'll consider one reference direction for determining VTH. I'll consider one reference direction here, either this direction or in the reverse direction, where we will consider only in the open loop reference direction. That is not current direction. This is reference direction in the open loop. Now, if I know the voltage in 2 ohms, I can determine VTH. If I know this voltage, I should know the voltage of this. Then only I can determine VTH. If I want the voltage in this, I want the current in this 2 ohm. See here, for determining VTH, I had to write the loop here, loop equation. So I want the voltage in this. If I want the voltage in this 2 ohm, then sum of all the voltages is equal to 0. Then you will get VTH. So if I want to determine current, if I know current multiplied by this resistance is voltage. So I will determine the current in this 2 ohms. Now, this 2 and 2 series are parallel.
Series.
Series. See
Series.
here, these are in series because current is not dividing here. Here open loop is there. That's why 2 and 2 are in series. If a closed loop is here, then current will divide in this. But current is not dividing here. Here open loop is there. That's when 2 and 2 are in series. Now here 2 loops are there. This is I1. This is I2. 2 loops are there in this. 2 closed paths are there. This is not the closed path. This is reference direction. Now, what is the current in this 2 ohm?
I2.
I2.
Okay. I2 is the current in 2 ohms. If I know I2, that is the current in 2 ohms. Now apply mesh analysis here. See here, I will apply the mesh analysis for determining I2. What is A11? What is A11?
Diagonal.
2 plus
Sum of all resistances in the first loop. 2 plus 4. What are the sum of all resistances in the second loop?
4 plus 2.
Okay. Now what is the A12 common element, first loop and second loop common element?
4.
4.
Plus or minus?
Minus.
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 I1 is in the downward direction. I2 is in the upward direction. Both are in opposite direction. Okay. Now here, this is I1 and I2. I don't want I1. I want I2. I2 is the current in 2 ohms. What is the voltage in the first loop?
8.
8.
8.
Plus or minus?
Plus.
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 Because see I1 in the first loop, I1 is flowing from minus to plus. Minus to plus means plus. Now what is the
Minus 4.
second? I2 is
Minus 4.
Minus 4.
I2 is flowing from plus to minus. Okay. Now I2. This value is 6. This value is 8. Okay. Otherwise, write down. Now I2, I want only I2 because I want the current in 2 ohms. I2 is equal to delta 2 by delta. Your delta 2 is replace the second column with voltage sources. Delta is determinant of this.
Zero point 0.25.
0.25 ampere. Now the current in this 2 ohms is 0.25 ampere. Because I2 is the current flowing in 2 ohms. I am determining only I2. Because I want only I2. 0.25 ampere. Now in the direction of I2 I can take plus and minus in the resistor. In the direction of current I can take I2. In the direction of current I2 I am taking plus and minus. Okay. Now I have applied mesh analysis. Can you apply nodal analysis and determine the current in 2 ohms? Same current you have to get to 0.25. We will verify. Instead of mesh analysis, I will go for nodal analysis. Okay. Now see here, how many nodes are there?
2 nodes.
Two. Only one node is there. Because here node is not there. Current is not dividing. If current is not dividing, this is the only node. V1. Because here if current divide, if one more branch is there here, then it will become node. Now it is not the node because current is not dividing in these two. These are in series. These 2, 2 and 4 volts are in one branch only. This is only one branch. This 2 ohms, 2 ohms and 4. This is only one branch. Here node is not there. Okay. Now apply nodal analysis. If suppose if resistance is here, then it becomes the node. If closed path is here, one resistance is there, then it becomes the node. Now here open circuit is there. Current will not divide. Here 2 and 2 are in series now. Okay. Now write down the nodal equation. Assume all the currents are leaving from the node point. V1 minus 8 by 2 plus V1 by 4 plus V1 minus 4 by 2 and 2 are in series. This is the nodal equation. If you are having doubt, you can ask me. Is it okay? Sorry. V1 is 5 volts. Are you getting 5 volts?
Yes, sir.
Okay. V1 is 5 volts. Now I don't want V1. I want the current in this 2 ohms. Current in 2 ohms is equal to V1 minus 4 by, assume the current in this as I, these two are series, by 4. 5 minus 4 by 4. That is 1 by 4, 0.25. Same thing we got in mesh analysis also. Okay. The current in this 2 ohm. Assume a current direction like this in the downward. In the direction of current, I will take plus and minus. So in exam, you can apply anything, either mesh analysis or nodal analysis. Even you can apply current divider rule also. Because I want the current in this 2 ohms. Current in this 2 ohm I have determined now. Now I got the current in 2 ohms. 0.25. Now I will write the loop equation here for determining VTH. Now I want to write VTH minus VTH plus minus 2 plus plus 4 minus 2 plus plus 2 into I. Current I is 0.25. That's why I am determining the current in this 2 ohm. If I know the current in this 2 ohm, I can determine VTH. Two into 0.5, how much?
4.5.
This is the VTH. Now we have determined VTH. Then what you have to determine next?
RTH.
RTH. For determining RTH, short all the voltage sources. I'm short circuiting all the two voltage sources are there. Short circuit these two voltage sources. If RTH is this side, you have to calculate from the opposite side. This 2 and 4 are parallel. Parallel is in series with 2. Again, this entire combination is in parallel with 2.
Four ohms.
4 ohms. Okay. We get 4 ohms. See properly. Is it 4 ohms? It is 1.25 ohm, I think. See properly.
Sir.
In your textbook,
The
it is
total answer is 4, sir.
okay. Total
RTH
answer
is
is okay. Your RTH in your textbook they have given this one. Now,
1.2.
okay. This is your VTH. This is your RTH. What is the resistance you have removed? 6 ohm. Therefore, I is equal to VTH by RTH plus 6. You know VTH and RTH.
Nine point
4.5 VTH. RTH is 1.25 plus 6.
9.6.
No.
0.621.
0. Okay. 4.5 by 7.25. 0 point something will get. 0 point. What is the value? Not audible.
0.62.
0
62 amp.
0.62 ampere. 0.62 ampere. This is the current in 6 ohms. Okay, that's all about the Thevenin's theorem. Next, we will go for the Norton's theorem. Norton's theorem. Norton's theorem. Write down the statement. Any linear bilateral network, any linear bilateral network can be converted to single equivalent current source, single equivalent current source in brackets Norton's current IN, in brackets Norton's current IN, in brackets Norton's current IN, in parallel with single equivalent resistance, in parallel with single equivalent resistance brackets Norton resistance Rn, Norton resistance Rn, Norton resistance Rn. See the statement. Any network can be converted into single current source IN in parallel with Rn. So this is the equivalent circuit. Draw the equivalent circuit. Any network can be converted into like this. In Thevenin's theorem, how we have converted?
Series.
In series. Always resistance will be in series with the voltage source. But in current source, always resistance will be in parallel. In source transformation also, we have stated the same thing. Always resistance will be in series with the voltage, but in parallel with the current source. This point is very, very important. Suppose if any resistance is in series with a current source, what will happen? It will bluntly burnt out. Okay, that will be burnt out. If any resistance is in series with the current source, that will be burnt out. So resistance should not be in series with the current source. Always resistance should be in series with the, in parallel with the current source. We'll do an example, then you can understand. Determine the current in 7 ohms. Determine the current in 7 ohms using Norton's theorem. Determine the current in 7 ohms using Norton's theorem. Determine the current in 7 ohms using Norton's theorem. So write down the first step. In Thevenin's theorem, we have opened the 7 ohms, but in Norton's theorem, what we had to do is we had to short circuit it. We had to short circuit that. Thevenin's theorem lo em chesamu 7 ohms open chesi VTH you have considered. But in Norton's theorem, we'll short circuit this. In Norton's theorem, we'll short circuit this. And I'll assume the current flowing in this short circuit is ISC. SC means short circuit. We can ISC and IN are both one and same. ISC means short circuit current or Norton current. Both are one and same. Take any one notation, either ISC or IN. Both are one and same. We'll short circuit that 7 ohms, and in place of that 7 ohm, we'll consider short circuit current. In Thevenin's theorem, we have opened. In open circuit, you'll have the voltage. In short circuit, you'll have the current. Write down note. In Norton's theorem, write down note. In Norton's theorem, short circuit the resistance. In Norton's theorem, short circuit the resistance. Short circuit the resistance where they are asking to determine the current. 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 So problem lo మీకు 7 ohms లో determine చేయమన్నారు. So 7 ohms ని short circuit చేసాం. We have shorted the 7 ohms and we are determining the current in that 7 ohms. Previous గా మీకు థెవెనిన్స్ థియరం అయితే అది ఓపెన్ సర్క్యూట్, బట్ హియర్ షార్ట్ సర్క్యూట్. షార్ట్ సర్క్యూట్ లో కరెంట్ ఫ్లో అవుతుంది, ఓపెన్ సర్క్యూట్ లో వోల్టేజ్ ఉంటుంది. Now here I will determine ISC. For determining ISC, I will take the loop analysis. I1 and I2. Two closed paths are there. There is no open circuit here. Both are closed loops. Now I2 is equal to ISC. If I know I2, that is equal to ISC, short circuit current. See, in that branch I2 is flowing in 4 ohms. With 4 ohms low, I2 flow out. That is one branch. Whatever the current flowing in 4 ohms, that is your ISC, short circuit current. So if I know I2, that is equal to ISC. Apply the mesh analysis. 2 plus 3, 5. Sum of all resistances in the first loop. 2 plus 3, 5. 3 plus 4, 7. Sum of all resistances in the second loop. 3 and 4 in the second loop. What is the common element?
3
ohms.
Minus 3. Current I1 is in the downward direction, I2 is in the upward direction. Now I want I2. I don't want I1 because I want the current in this branch. I don't want the current anywhere here. I want current only in ISC, in this branch, ISC. I2 is equal to ISC. How much? 1 point?
1.5.
1.5.
That is the current. Now I had determined short circuit current. Okay, now we'll determine Rn. Rn is the Norton resistance. Note down, write note. Rn and RTH are same. Write down. RTH and Rn are same. Note. Rn and RTH are same. Why means while determining RTH, we have shorted all voltage sources and open all current sources. Similarly, while determining Rn also, we will short all voltage sources and open all current sources. See here. Here, in place of this opened short circuited 7 ohms, consider Rn here and short all the voltage sources. So wherever you have shorted the resistance 7 ohms, there you consider Rn. Previously you have considered RTH, now we are considering Rn. Rn and RTH are same. For determining Rn, short all the voltage sources and open all the current sources. Now see 2 and 3 are in
Parallel.
parallel. If Rn is this side, calculate from the opposite side.
Five point two.
5.2.
5.2.
2.
Okay. Now I will draw the equivalent circuit. What is the resistance we have shorted?
7.
7. In the problem, he is asking us to determine the current in 7 ohms. So now here for determining the current in 7 ohm, I will apply the current divider here. This IN is coming here. This IN is dividing in these two branches. I want the current in 7 ohm. Current in 7 ohm is equal to total current. Total current for these two branches is IN. What is the opposite branch for 7?
Rn.
Rn.
5.2.
Opposite branch resistance by total resistance of parallel branches. 7 and Rn are parallel. In parallel, current will divide. So I want the current in 7 ohm. For 7 ohms, opposite branch is Rn. Total current into opposite branch resistance by total resistance of parallel branches.
Zero 0.49.
Okay, 0.49. Approximately 0.5. Okay, 0.49. Otherwise, you can write 0.49. Okay. Now I'll verify whether this answer is right or not. So write down verification, siding, verification. verification side. Draw the original circuit. This is your original circuit. I'll apply nodal analysis for verification.
Five point 43.
5.43. Okay. Now I want the current in 7 ohms. Current in 7 ohms is equal to V1 by 4 plus 7. See, V1 correct or not? Okay. Tell me how much you get.
0.49.
Okay. 0.49. Same thing we got in theorem also, Norton's theorem. Current in 7 ohm. So in exam, if they are asking theorem, we have to do in the theorem procedure only. This is only for the verification purpose.